What if I told you that more than 3,000 years ago, long before calculators, computers, or even the modern idea of algebra, someone was solving mathematical problems that would still look familiar to us today? They were calculating the area of fields, working with fractions, solving problems involving unknown numbers, studying right triangles, calculating square roots, and looking into the night sky, trying to predict what the moon and planets would do next. But here's the strange part. They didn't write mathematics the way we do. They didn't have the symbols you learned at school. They didn't have a calculator. They didn't even have paper. Instead, they had clay. And with a simple reed stylus, they pressed tiny wedge-shaped marks into wet tablets. Thousands of years later, some of those tablets are still here. And when historians began to decipher them, they discovered something extraordinary. The people who wrote these tablets were doing mathematics far more sophisticated than we might expect from a civilization this ancient. So who are these people? Why were they so obsessed with numbers? How did they calculate without modern tools? And how much did they actually know? To answer that, we have to go back. Not hundreds of years, not 1,000 years, but thousands of years, to a land between two great rivers, Mesopotamia. Look at a map of the ancient world. There, between the Tigris and Euphrates rivers, lies Mesopotamia. Today, much of this region lies within modern Iraq. But thousands of years ago, this land became the home of some of the earliest cities in human history. Water from the rivers made agriculture possible. Agriculture created food surpluses. Food surpluses supported larger populations. And larger populations created something new: complex societies. There were farmers, merchants, builders, priests, officials, workers, and scribes. And once thousands of people began living, trading, farming, and working together, one problem appeared. Someone had to keep track of everything. How much grain was produced? How much was stored? How much did a worker receive? How large was a field? How much did someone owe? How many animals were owned? Numbers were no longer just useful. They became necessary. And this is where the story of Babylonian mathematics begins. But there is an important detail. When we say Babylonian mathematics, we are actually talking about a much larger Mesopotamian mathematical tradition. Babylon became one of the most famous cities of the ancient Near East. But the mathematical tradition did not begin with Babylon alone. It developed over centuries, with important contributions from earlier Mesopotamian civilizations, including the Sumerians. Knowledge was inherited, copied, modified, and taught to new generations of scribes. So Babylonian mathematics wasn't created overnight. It was the result of centuries of accumulated knowledge. And much of that knowledge was written on something surprisingly ordinary: wet clay. Imagine holding a piece of clay in your hand. Soft, wet, malleable. Now imagine that this is your notebook. You don't have a pen. You don't have paper. You have a reed stylus. You press the stylus into the clay. One mark, then another, then another. Each wedge-shaped mark becomes part of a writing system known as cuneiform. And when the clay dries, your calculation can survive for thousands of years. This is one of the greatest accidents in the history of mathematics. Paper disappears, ink fades, but clay can survive. And because of these tablets, we can actually see some of the mathematics ancient Mesopotamian scribes were learning and using. Not guesses, not legends. Actual calculations preserved in clay. Now comes one of the strangest things about Babylonian mathematics. They didn't primarily think in tens. They thought in 60s. Their mathematical tradition used a sexagesimal, or base, 60 system. And you might be wondering, why 60? We don't know exactly why this system became established. But mathematically, 60 is extremely convenient. It can be divided by many numbers: 2, 3, 4, 5, 6, 10, 12, 15, 20, 30. That makes many fractions easier to represent. And here's the part that might surprise you. Look at the clock on your phone. 60 seconds. 1 minute. 60 minutes. 1 hour. Look at a circle. 360 degrees. These modern conventions have a complicated history, but ancient Mesopotamian sexagesimal mathematics is part of the long historical story behind them. So when you look at a clock, you are looking at something connected to a mathematical tradition that is thousands of years old. Now imagine you're an ancient Babylonian student. Your teacher gives you a problem. There is a quantity you don't know. You are given information about it, and you have to find the answer. Today, you might write x equals something. But the Babylonian student didn't have our modern algebraic notation. Instead, the problem was written in words and numerical instructions. And yet, the reasoning could be surprisingly sophisticated. They solved linear problems. They worked with quadratic problems. They manipulated quantities. They used systematic procedures. In other words, they were dealing with problems that we would recognize as algebraic today. But here's the important distinction. They did not have algebra in exactly the form we learn it today. No x, no y, no modern equals sign. Instead, they had procedures. And those procedures could be incredibly powerful. But why would anyone need this mathematics? Imagine you own a field. It's rectangular. You need to know its area. You need to know how much seed is required. Perhaps taxes depend on the land. Perhaps you need to divide it. Perhaps you need to determine an unknown length. A simple mathematical mistake could have real consequences. So scribes developed methods for calculating areas and lengths. Geometry wasn't just something to write on a tablet. It was connected to agriculture, construction, administration, and everyday economic life. Mathematics was becoming a tool for controlling information. And information was power. Now we come to one of the most famous objects in the history of ancient mathematics. Its name is strange. Plimpton 322. It's a clay tablet. At first glance, it doesn't look like something that could change our understanding of mathematics. But its numbers are extraordinary. They are connected with what we now call Pythagorean triples. For example, 3, 4, and 5. Because 3 square plus 4 square equal to 5 square. Today, students learn this relationship through the Pythagorean theorem. But the Babylonian tablet dates to a period centuries before the Greek mathematician Pythagoras is traditionally associated with the theorem. Does that mean the Babylonians discovered the Pythagorean theorem? We need to be careful. The tablet does not present the theorem in the modern form. A square plus b square equals c square. And historians still debate exactly how Plimpton 322 was intended to be used. But it clearly demonstrates that Mesopotamian mathematicians were working with sophisticated numerical relationships involving right triangles. And that discovery forced historians to rethink what ancient mathematics really looked like. Now imagine trying to calculate a square root. Without a calculator. Without a modern algorithm. Without even the notation you use at school. Sounds difficult, right? Now imagine doing it more than 3,000 years ago. One Babylonian tablet, known as YBC 7289, contains a remarkably accurate approximation connected with the square root of 2. The modern value begins 1.4142136. The Babylonian value represented on the tablet is astonishingly close. This wasn't random guessing. It shows a sophisticated understanding of numerical approximation. And this is one of the reasons Babylonian mathematics continues to fascinate historians today. These weren't simply people counting objects. They were developing mathematical techniques. But perhaps the most fascinating part of Babylonian mathematics begins when the scribes stopped looking at the ground and looked at the sky, the moon, the planets, the stars. The Babylonians carefully observed celestial events. They recorded what they saw. Then they looked for patterns. If something happened at a particular time, would it happen again? Could its movement be predicted? Could mathematics turn observations into forecasts? Over generations, Babylonian astronomers created large collections of observations and developed numerical methods for predicting celestial phenomena. This was a major intellectual achievement. They were turning the sky into data. And once the sky became data, mathematics could be used to study it. But there is something we often forget when we talk about ancient mathematics. behind every tablet, there was a human being. Someone held the stylus. Someone made the marks. Someone learned these procedures. Someone probably made mistakes. Someone had to correct them. Someone taught another person. And someone carefully preserved the tablet. We don't know the names of most of these ancient mathematical scribes. Their identities disappeared. Their voices disappeared. Their faces disappeared. But their calculations remained. Think about that. Thousands of years later, we can still see the work of people whose names we will probably never know. Their mathematics survived them. It's tempting to look at these discoveries and say, the Babylonians were mathematical geniuses. But history is more interesting than that. Their achievements were not the result of one person suddenly inventing everything. They were the result of a culture that preserved knowledge. Teachers taught students. Students copied examples. Scribes created tables. Astronomers recorded observations. Administrators used calculations. Generation after generation, the knowledge accumulated. That may be one of the greatest lessons from Babylonian mathematics. Human knowledge doesn't always advance because of one genius. Sometimes, it advances because people preserve what they learned and pass it forward. For the Babylonians, mathematics was not simply about solving puzzles. It was connected to real life. Land, grain, trade, wages, construction, administration, time, astronomy. The more complex society became, the more useful mathematics became. Numbers allowed people to measure things that were otherwise difficult to control. A field could become an area. A quantity of grain could become a number. Time could become a calculation. The movement of the sky could become a pattern. Mathematics transformed the world into something that could be recorded. And once something can be measured, it can be compared, calculated, predicted, and controlled. Civilizations don't last forever. Babylon rose to enormous power. Then political control changed. Empires came and went. Languages changed. Rulers changed. But knowledge has a strange ability to travel. Mathematical traditions continued in Mesopotamia long after individual kingdoms disappeared. Tablets were copied. Scholarly traditions continued. And mathematical knowledge became part of the larger history of science and astronomy in the ancient world. The people who wrote those tablets could never have imagined that thousands of years later, researchers would still be studying them. So, why should we care about Babylonian mathematics today? Because the story is bigger than Babylon. It tells us something about humanity. Long before modern universities. Long before scientific calculators. Long before computers. Humans were already asking mathematical questions. How much? How far? How large? How many? When? And what happens next? The Babylonians turned those questions into numbers. They built methods for calculation. They developed sophisticated numerical traditions. They studied geometry. They worked with problems involving unknown quantities. They created numerical tables. They studied the heavens. And they left their work behind, pressed into clay. Today, we live surrounded by mathematics. Our phones use it. Our buildings depend on it. Our computers depend on it. Our GPS systems depend on it. Our economies depend on it. And every time we look at a clock, we see 60 seconds in a minute, and 60 minutes in an hour. Thousands of years ago, a Babylonian scribe could not have imagined a smartphone. They couldn't have imagined a computer. They couldn't have imagined YouTube. But they understood something fundamental. The world contains patterns, and those patterns can be described with numbers. Perhaps that's why their mathematics survived. Not because the clay was special, not because the people knew the future, but because they left behind something humanity would never stop using. Numbers. The cities of Babylon eventually became ruins. The scribes disappeared. The tablets became buried. And for thousands of years, they waited. Until someone found them. Until someone read them. Until someone realized that the ancient world had been doing mathematics all along. And perhaps the most remarkable thing about the Babylonians isn't how old their mathematics is. It's how familiar some of it still feels. Because when we solve an equation, measure a shape, calculate a fraction, or look at a clock, we are continuing a story that began thousands of years ago. A story written, not in ink, but in clay. And the numbers are still speaking.